Let's talk about some perspectives on a kitchen. There's a lot of different ways you can approach and look at a commercial kitchen. Just like there's a lot of different ways you can approach and look at different parts of life, if you will. In the course, I talk about ventilation. I talk about human health. I talk about fire protection, energy use and operational costs, relationships between systems or interconnected systems, I call it. Anytime there's been design and redesign, you might call renovation concerns, and then codes and responsibilities. So there's a lot of different ways to look at a commercial kitchen. As inspectors, we mostly are going to rely on these standards that we have, but you're going to want to have this other knowledge about the different ways that systems connect in a commercial kitchen space. What is the area in a home where you have the most different types of systems that are exposed in a home? Attic is close to my answer. Attic's not quite my answer, but it's not far from it. Kitchen, you think? I think it's the crawl space. I think it's the crawl space. So because you're seeing plumbing, you're often got HVAC, you got electrical for sure, you got structural, you got insulation, you got moisture issues, you got the foundation wall. There's a lot going on in the crawl space. My point is a commercial kitchen is a little bit like that. A lot of this stuff is exposed in a commercial kitchen. It's like a mechanical room in some ways, except that there's fire. Except that there's active use of fire and fuel. So be aware of that when you step into these spaces. That's why they're special. I think that's why they're worth having a course on. In the dining room, you have an HVAC system that has its own supply and return, is what we call it in residential, right? What it's missing is most kitchens. I can't think of a kitchen I've been in that doesn't have its own HVAC system. So that's not in here. But the point here is you have airflow in coming at something like, well, we don't have it labeled on the left side, but the cross flow is coming into the kitchen at, say, 1,000 CFM, cubic feet per minute. Makeup air is being pushed in at 7,000, and the air being taken out by the exhaust hood is at 8,000. So the point of makeup air, in other words, is to balance the loss of exhaust air so that you don't have what's called negative pressure coming, just sucking air out of the dining room to where the dining room air handler has to overwork to cool two spaces. So that's why this is funny to me, because the kitchen would certainly have one too, but you still could have that negative pressure. Okay, so that's why there's makeup air. Are you going to do all those calculations? On most inspections you do? Probably not, unless you really get into specializing. But it's important to understand why it's there and how it operates, just from a very beginning point of view. So in other words, if you didn't have the right side, if you just didn't have the makeup unit, what you'd have happen is have to pull 7,000 more CFM from the dining room. So essentially the downblast makeup air is kind of holding that other air at bay, if you will, and keeping it in the dining room where it belongs. So I think a lot of like a Bojangles or sort of like a maybe a restaurant you've been to that has a lot of solar gain and is super hot in the dining room. I can think of several in Raleigh. They have to work really hard to almost keep, it's almost like an air wall, if you will, is what the makeup air is doing to try to keep them balanced. So a lot of times you'll see one of these units failing faster than the other, for instance. And when you understand what's going on here, you can start to piece that together for your client. Again, this is just your baseline. As you go and apply this stuff and you're talking to your clients and you're looking at the different pieces, that's going to help you put together the problems on site.